Why do we use soap to wash dishes? The main reason is because dishes get greasy. Water can't wash off grease, but soap can. But why does soap clean off grease when water doesn't? Water is a polar liquid, which means that each water molecule has a positive end and a negative end. This means that water molecules are attracted to each other like little magnets. Oils, on the other hand, are nonpolar, which means that all parts of the oil molecule are pretty much neutral. Oil molecules are way less attracted to each other than water molecules are. This is why water tends to bead up on surfaces, but oil spreads out. The water molecules hold together, but the oil doesn't. Because water is polar and oil is nonpolar, when they touch, there is a tension at the boundary between them. A water molecule at the surface is attracted strongly to the other water molecules behind it, but only weakly attracted to the oil molecules in front of it. So the water molecules feel an overall pull backwards into the rest of the water. This is surface tension. Because the boundary between water and oil is under tension, the most stable state for a mixture of water and oil to be in is one where they touch as little as possible. In the same way that a rubber band will cling as closely as possible to something if it's stretched around it, the water and oil move around in order to minimize the tension from touching. Imagine we pour some water into a big container and then add some oil on top of it. The oil will float on top of the water in one big mass, and so the water and oil will only touch at one surface where the two halves of the container meet. But if we break up the oil into smaller pieces and mix them into the water, like this, then the oil and water start to touch each other way more. All the little pieces touch the water all along their boundary, and even though we have the same amount of oil, there is way more area where the liquids touch. In this example, it's over 6 times as much. In fact, the more pieces you break the oil into, the worse this actually gets. The more we mix in the oil, the more area there is where it touches water. This extra area means a lot more energy in the system because of all the tension at the boundaries. One of the most basic rules of physics is that systems will always rearrange to get rid of all the energy they can, so the mixed up state, which has a lot of energy, will work its way back to having two big masses. This is why when you make a vinaigrette, you have to stir it really well. You have to put in all the energy that it takes to keep the drops separated. And it's also why it doesn't take very long for it to get separated again, because the system works its way back to the lower energy state. So we know why water and oil don't mix, but how does soap help? Soaps contain molecules called surfactants. Surfactants reduce the tension at the boundary between polar and nonpolar liquids. This lets them mix more easily. For example, this Palmolive dish and sink contains ammonium lauryl sulfate, which looks something like this. The key property that this molecule has is that part of it is polar, and part of it is nonpolar. It has a long tail made of carbon and hydrogen atoms that's nonpolar, and a head made of sulfur, oxygen, nitrogen, and hydrogen that is polar. Most surfactants have this sort of structure, so we'll represent a generic surfactant like this, with its nonpolar tail and polar head. So how does a surfactant like this reduce surface tension? When you add surfactant molecules to a mixture of oil and water, like the one we showed earlier, they move into the boundary between the liquids. This picture is, of course, not to scale. The polar heads stick into the water, and the nonpolar tails stick into the oil. This makes both the oil and the water happy, so to speak. The water molecules are attracted to the polar heads, and the oil molecules are attracted to the nonpolar tails, so there is less pull and so less tension at the boundary. Because there is less tension at the boundary, the water and oil more easily mix together. When oil is mixed into the water, the surfactants coat the droplets. There is still some tension, so the oil and water won't just mix by themselves, but it's way easier to do than without the surfactant. So when you wash dishes without soap, it's really hard to get any oil off of the dish because it doesn't mix with the water. But when you add soap, the surfactants let the oil mix with the water and come off the dish, leaving it clean.